Okay, so this week we're going to be building the first part of the clock. So it's basically going to be programming the LCD and then building it. So this is the final product example. Today we're only going to be doing the LCD, wiring it up here, and then wiring up the potentiometer so we can control the screen brightness. The clock functions for today is going to be date and time only. So this is the LCD we're going to be using. I think last week we looked at the one that had all of these inputs, the 16 inputs, as well as the one with 4 inputs. But with the 16 input ones, you get more, you have more ability to change different things. So the first one is the ground. You just ground that, we're going to ground that one. And VCC is the input. V0 is what we're going to be connecting the potentiometer to control the brightness. RS will tell you if you're sending it commands or data. And then RW will be whether you're reading or writing data to the LCD. So we're going to write low or high using the ground pins. And then EN, when we set the pin to low, the LCD doesn't care about what's happening to RW and RS. But if set it to high, the LCD is processing incoming data. Pins 7 through 14 are data pins, so we're going to cover that. That's where we're going to be taking in information, and if we connect buttons, that's where you plug those in. And then the A and C control the backlight display, which we're going to use to control the potentiometer. So this is the example of the 4 input one that's on Tinkercad. This one only has a few things that you can input. So the 16 input one is better because you can control a lot more things. So when you're programming an LCD, you have to use the liquid crystal library. You have to include it, but I think the new update that they just came out with is already included in the download, so you don't have to actually download that library. You just have to do the hashtag include. And we're going to go over all of these commands to get the LCD working. So first, we're going to go to Tinkercad, and I'm going to hook it up. So we're going to need is everyone there? Breadboard. I'm going to use one of the longer breadboards. And an LCD. So I'm going to choose the regular 16:2. And place it somewhere that isn't the top 2 rows. So the first thing we have to do, like it was shown in the diagram over here, is connect the ground and the VCC to pin 1 and pin 2. So I'm going to do that over here. Also, if you hover over in Tinkercad, it tells you what each one is supposed to be hooked up to. So the last two pins are the AC pins. The anode and the cathode, they control the screen brightness. So when you go into the data sheet for the LCD, they tell you to connect the anode into the positive terminal. And then this one, the C, goes into the negative, and it has to include a resistance, and they suggest using the resistance of 220 ohms. So that's what we're going to be using. This one can go into the positive. And we'll need a resistor. 220 ohms. Connected to the negative. Yeah. You asked me about we can also already attach the potentiometer from here that we're going to use. Is it working now?
Yeah, there you go.
Okay. I'm going to move it over here. The only reason I'm putting it here is so it looks a little bit neater because of the way we're going to attach it later. So the potentiometer is just like last week. The two outer terminals, it can either be positive or negative, and the inner one is what sends the information. So I'm going to connect one of these to the negative and another one to the positive. So then we're going to need to get the Arduino so we can start connecting to the input pins of the Arduino. I'm going to flip it so that some of the connections are easier since most of the connections are going to be on this bottom side over here. So first thing we need to do is connect the Arduino to the board so we can power it. So we need to connect the ground and the 5-volt pin like we did last week. So if we go back here to the data, V0 is what controls the brightness. So this is where we're going to connect the potentiometer, and this is the third pin. I'm going to try and color code it so it's a bit neater. We go here to the next one, 4RS. It's used to say if it's sending commands or data. So we are going to be sending stuff to it, so we need to connect it to one of the pins. I'm going to connect it to just any pin that's not a PWM pin, so the ones without the tilde on the front. Connect it to 2. Next pin is the RW pin. We're going to be using this to write the information to the LCD. So since it's sending information, we need to connect it to one of the PWM pins. And this one, the one in the middle, the read write, we're going to connect it to the ground. So when we connect something to the ground, that means it's set at low. So when the RW is set to low, it says right here, it's in write mode, which means we're going to be writing stuff to the LCD. So usually when using LCDs, for some reason, I don't know why, people usually start these pins right here. See, DB0 all the way to DB7. People usually start from the right and move towards the left when setting up the data pins. So that is what I'm going to do. I'm going to set D4, 5, 6, and 7 as input pins into the Arduino. I'm going to do them all the same color, yellow. And then I'll explain later why we need 4 pins. So I'm just going to do them to the 7, 6, 5, and 4. So because our LCD is running on like the most basic thing ever, we're running it on 4 bits. So we only need 4 data connections. That's why we have 4 wires, 4 bits. If you were to do 8 bits, you would need to connect the rest of the DB0 pins. So now all we have to do is program it. This part is a little more complicated. I'm only going to program the time, and then the date is the exact same way, but I've already included it in the GitHub so that we can save some time so we can build it. I'm going to go to the code. I'm going to do it in text. So the first thing that we need to include is the liquid crystal library so that it can read the special commands. So with this library, if you go into Arduino reference and look at what the commands are for it, The first command that you need is just called liquid crystal. And this is how you set up which pins you're using. So you do liquid crystal and LCD. And here's where you put all the pins. So if you didn't use the same pins as me, you'll have to change your numbers. But you can see that I use pins 2, 3, 4, 5, 6, and 7 on the Arduino. So that's what I'm going to write. So this is just so the Arduino knows where the information is coming from. The void setup for the LCD is pretty simple. So another command that's included in there is lcd.begin. This is how you turn on the LCD. And basically you'll see when we turn it on, it's like a little matrix, I guess. It has 16 blocks going this way and 2 blocks going down. So 16 columns, 2 rows. So what you need to write is 16 times 2 so that it initializes all of those blocks. And to turn on the backlight, you'll see that the backlight and the blocks are different colors. So to turn on the backlight, you only need to do lcd.clear. And you can get all this information just by going into the Arduino reference, and it literally like spells it out step by step in YouTube. So right now you can run the simulation and see what happens. So you can see that it turns on, and you can see all the blocks in there. But obviously nothing's going to be written to it because we haven't told it to write anything. Is your guys working? Did you put a semicolon after? So if you turn the potentiometer, you can see that it goes and it changes brightness. Does she have it all written correctly? So the next command is the lcd.setCursor. So the cursor is where you're going to start writing things to. So the command for it is stop simulation. lcd.set. So how do you set the cursor? So you know how it was like a matrix 16 by 2? Wherever you want to start writing, those are the numbers you put in. So if you want to start at 0, 0, so the top left, you put in 0, 0. If you want to start at the middle, at the top, you can write 6, 0, or you can write 6, 1 if you want to start at the next row. But you're bound by 16 by 2 because that's the maximum value. And then to write anything to the LCD, all you have to do is lcd.print. And write whatever you want in quotations. I'm going to do So if you want, you can change where the cursor starts and see how it changes. Or if I set the cursor to, you can see that it moves over. So the next thing you have to do, everyone got that, is set up the serial connection. So you usually include this if you're going to be sending a lot of information to it, different information. Since our clock is going to be constantly changing the time, we need to set this up. We're going to do serial.begin 9600. You go into the data sheet, it explains that the 9600 is how many bits per second it's transferring. And this is the maximum that that LCD can transfer at. So now I'm going to write the code for the time to change. So I'm going to do this manually, which is a bit more complicated, I guess, but it's better for you to learn how to code. So I'm going to erase what's in the void loop because we're going to be incrementing the time basically. So I'm going to be using S for seconds, and I'm going to set S1. So basically what it's going to be doing the loop is it's going to say S+1, and then it's going to loop it again, and it's going to be 2, 3, 4. But what happens is if S is equal to 60, then the minute goes up by 1. So I'm going to set minute goes up by 1. And once the seconds hit 60, they automatically go back to 0. So this is how we're going to increment the seconds and the minutes. So it's basically saying the seconds are going to count up to 60. And when the seconds get to 60 seconds, it's going to go up 1 minute and set the seconds back to 0. So what you can do now is if you want to try and write the minutes one, it should be the same thing, but instead of incrementing the minutes, when it gets to 60 minutes, you should increment the hour by 1. So I'm going to do minutes equals 60. So we're just repeating what's above, but instead of minutes, it's hours now. And set the minutes to 0. So we want this loop to happen every 1 second so that it goes up every 1 second in increments. So we need to delay it, the whole loop, by 1 second, which is 1,000 milliseconds. So basically we're just running the loop every second and incrementing it. And I'm going to clear the LCD every time I do that so that it updates. So one thing we have to do before we move on to the next section is we have to initialize the variables that we used. Go up at the top, not in the void setup. I'm going to initialize. So these are all integers. Set them all to 0. But if you want to set it to a specific time, you can just change the hours to whatever you want. Here?
Yeah, it's just I think the hair's going on.
So if I wanted to start this at like 4 o'clock, I just have to change the hours to 4, and that's what they would show. So now this isn't actually printing anything through the LCD right now because we haven't used the print statement. So what I'm going to do is I'm going to output all this data to the LCD. So this is where we're going to do the output data. So I'm going to try and center it. So I'm going to set the cursor to 4, 0. That's sort of the center. It's an even number, so it's not exactly going to be in the center, but so I want each one of them to have 2 digits. So instead of it, if it's a minute, it might display here. I'm going to write right here. So if we were to just display print H, print S, print minutes, it would be something like 4, 2, 3, something like that. And that looks kind of ugly. So I'm going to, for the numbers that only have 1 digit, I'm going to add a 0 to the front, so that they're all 2 digits. So I'm going to do H is less than 10. That means if it has only 1 digit, you're going to do lcd.print, add a 0 to the front, and then you're going to print the time. If it's a variable, you don't need to include quotation marks. All right, else if it's any digit above 9, so it's a 2 digit, you can just print whatever value it is. And then to make it look like a clock, you need to print the semicolon. Now we can just copy this whole section here. Paste it again. And replace the H with M, because we're going to do the same exact thing for minutes. And then you can do it one more time, copy and paste, and change it to seconds. What do I do here? So if you run the simulation, you should see it incrementing. Let me delete this one. Oops. Oh, I did accidentally print F. right, well, my thing is loading, but I accidentally wrote printf instead of regular print.
Refresh.
I'm gonna take out the printf. Where is let's see here. Oh, I forgot that this is case sensitive. So the serial.begin is case sensitive. It needs to have a little s. Let me see. So I just had to debug it. I had some spelling errors, but it should work if you run yours. Okay. So let me see, what time is it right now? 3:39. I'm gonna set the hour to, let me stop simulation. I'm gonna do, this is a 24-hour clock, so 3 is 15. And the minutes 39. If I start the simulation. Oops. You're right. You're right. Dang, my Wi-Fi is. Did it work for you guys? No, it's not. Switching to? Yeah. Why to? Oh, wait a minute. Is it working? Yes. Oh, okay, so these brackets is supposed to be this. Yeah. So all of these go, yeah. Yeah. Are you holding shit? Okay, maybe I will. Did everyone get their sword? Is yours working? No. Is the. As far as the wiring, can I see it? Here, you can check it from here, since I don't need this anymore. So for, if yours is working, the date and time, I did it in the exact same way, but instead of doing the semicolons, I did a slash. And instead of doing I did the numbers the exact same way. And then there's some other increments that are different, like some months are 30, 31. That's just like a small caveat. But if you go to the GitHub, I posted the rest of the code for the date. So I'm going to just copy and paste that whole section. If you want to look over it, you can. But it's basically the same thing all over again.
Is it because of this maybe, or like it's, is it supposed to be like that like every time?
Yeah.
And then the same with this, right? With the else. If else.
So this is all the code that we just wrote. Is yours working?
Yeah.
Oh,
no,
no,
yeah, I don't
it's
have
harder.
oh, sorry. Oh, missing?
I don't think you are anything. Oh,
Right there.
the line right above it.
Oh, okay.
No, to the.
Yeah. Awesome, thank you.
See what it says.
Uh,
See, I don't know why you're not getting the kind
and this is supposed to be like this, right? Also do but like after everyone, after every minute,
Yeah.
second,
except the last one.
Oh,
we
nothing.
Scroll up to see what.
Oh,
Oh, yes. Scroll up. That's before all. You have to delete that one. 28.
So if you go to the GitHub, it's included on the sign-in form. I have the rest of the code for the days. If you just want to copy and paste it and look over it, just so there's enough time to build the circuit. So if you go to clock day 3, it'll have from line 68 all the way to the end, all the way to 122. That's the coding for the days. I'm gonna just take that whole thing. You don't have to copy the last 2 lines where it increments the seconds because we already did that. I'm just gonna paste all that in. For the, if you go into, here, I'll do the sign up. So if you scan this form, one of the links on there is the GitHub link. Or you can go to this URL.
Also posted it.
Okay, so it's
Oh,
not
you posted it with
Yeah.
this org. And you also need to initialize here the ints for the months and days.
That's neat.
Did you get the date to work?
Yeah.
So it should be clock day 3. You'll need to copy that top line where it initializes the month, day, and here, let me see. Line 7. And then line 68 all the way to 122.
Can I update the full code?
Yeah, but then you'll have to delete what you have.
Because it would be-
Okay, yeah. I mean, if you want to. So now, when you put this into the Arduino IDE, which you should have downloaded from last week, you can upload it into the Arduino and it'll do exactly that. So I'm gonna turn on the lights so we can build them. If everybody's is working. Yours is working, hers is working.